Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. In today's episode, we've got a very special guest all the way from Micro Commercial Components. It is Sannah Vinding. Thank you for being here today on the podcast.
Thank you, Robin. I'm so excited to be here.
Fantastic. Now, just before we go into this podcast, last time we tried to record this, we had a bit of a power cut that kind of came out of nowhere. Just as we were literally about to start, the whole thing goes out and I couldn't see anything and I was literally trapped in this studio section. Anyway, so we can finally do the podcast, finally do this conversation. We've been waiting for so long. My first question to you, could you just briefly talk to the audience who you are, what you do, and what it is that you do at Micro Commercial Components?
Yeah, and let's call it MCC, right?
MCC.
You can see it here. That's easier.
Oh,
yeah,
yes.
Let's make it.
Well, my screen's mirrored, so actually I'm seeing CCM all in backwards.
Oh. I'll take both of them. No, yeah. So I'm responsible for the digital marketing at MCC. So I'm the digital marketing director. So leading everything around it. So my background a little bit here. I'm an engineer, and I expanded into marketing many years ago, and I think that just makes it unique, right? Because combining the technology, the communication, how do you communicate to all the engineers? So responsible for a lot of what you see if you sign up for newsletters, or if you see what's on the website, how we communicate all the new products that we spit out. So that's about me.
I think it'd be fair to say we're a bit of a rare breed. You tend to find that engineers stick to engineering, and those who go into sales and marketing stick in that area. But when you get the two coming together, it's quite a powerful force, I've noticed, and that makes us two quite rare in the industry. So it's nice to talk to somebody else who knows both sides. So we're talking about MCC. So my first question: what is MCC, and what does it do for engineers?
Yeah. So we are a discrete semiconductor manufacturer, and we're actually an integrated one. So we have the whole, devices from the raw material to we make the wafers, we pick them, we package them, and then we also, we send it out. So we do the whole thing. From the beginning to the start, which makes us unique, because that's just, if there's anything specific or with the capacity or what you need, we're actually standing behind it. And then we also go into all the different vertical integration. I'm sure you've seen, but that's other like us, right? But we're like really strong in the industrial, in automotive, in computing, and consumer.
So that makes MCC a semiconductor like a series of semiconductor foundries. Is that correct?
Yeah. So it's the IDM, right? That's what they call it, so integrated device manufacturer. So we control with the supply chain. That's the whole cost efficiency. We can be more flexible. We have control over, of course, the quality. If there's anything with customization, it's the whole thing.
And so that allows smaller companies, or even large companies, if they want to build a semiconductor device, but they don't want to invest in the money to build the facilities and all that jazz, that's when they come to you, and you guys then turn around and say, right, we'll make that for you, no worries, we'll package it and stick it out there.
We need volume, okay?
Volume. They need volume. But overall, you're basically doing that essentially.
Yeah, but again, right? We have like over 10,000 components in our portfolio. So again, we look and saying, okay, what is it that we hear from our customers, right? What is the demand? Do we have any gaps, right? Where is it that we need to be? So we can support with our portfolio, and then that's where we support our customers.
And so you don't just do custom devices for customers. You'll also do your own devices that you design yourself and put into the market.
Yeah. That's the main focus. Yeah.
Oh, fantastic. Yeah. So what kind of components are we talking about then?
What are we talking about? So all that, it's like diodes, it's MOSFETs, it's IGBT, it's silicon carbide MOSFETs as well, TVS, and ESD protection. So we're like all over. There's also power modules. So different ones. And again, they're also strong, right? Depending on what vertical you're using them in.
Fantastic. So, as a semiconductor fabricator and I suppose what would you call it, a third-party manufacturer as well, a foundry, what are the challenges that you see engineers facing in that area up till this day?
I think it's complex, right? There's so much disruption over the last couple of years, and it won't stop, right? If it was the pandemic or with the geopolitical, there's always something coming up, or it can be the weather, right?
It really can be, yes.
Yeah, no, but so it's not like you can sit back and saying, "Oh, past
Mm,
that, right? Now we can." So looking at the whole supply chain strategy, if you are a manufacturer producing and designing devices, you have to be sure that you're not single source, right? You have to
yeah.
have a multi-source strategy. So that's where we come in and can support and being, having a cross or something like that. But other thing is that when you look at all the devices that's around us and how everything gets more digital and how everything communicates with each other, is that devices are getting smaller and smaller,
Mm,
especially if you look at the consumer part. So challenge as well is also how do you make sure that these devices has enough battery, right? Because that's you want to have that battery
yeah.
longer life for everything. Um, you want to make sure that it's not overheating, right? There's a lot of thermal management you have to control as well. So that's where with the components that we introduce as new product devices or new product components, we make sure that it fits in, right? We can support with this. If it's the power management, right, or if it's the thermal, that's where we can go in, because that really is a challenge for the design engineers right now.
And so, source. So we're saying sourcing components, especially in times when you might have semiconductor shortages or supply issues.
Yeah,
What
yeah.
about what would you say about the recent events going around, the geopolitical events around the world with these kind of trade embargoes coming in? How have you guys dealt with that?
Um, so I think there's a lot. So we do have manufacturers in China,
Hmm.
but we actually started like a China plus one strategy as well. So we are
Hmm.
building a new facility in Vietnam.
Hmm.
So that is a way to offer if there's any specific concern
Yep.
with any of the manufacturers right around the world, saying, "Hey, we need options."
Hmm.
So that's how we are opening up and saying, "Hey, we can actually provide you with the options, and also can help with the capacity, right? Because
Hmm.
again, there's a lot of components on the shelves. We've seen what's going on this year, right? It's like adjusting again, right? That's
It is.
what's
Yeah.
happening. Yeah. But at a certain point, right, you need to be ready and get out of the gate as well. So by building this
Hmm.
extra facility in Vietnam, make us stand out as well to be able to support for that future that is coming. And if you're looking at
Hmm.
all the trends and what's going on, right, it is there. We're just all waiting for and saying when, when is it
It
going
will
to
come. It will come, and it's probably
happen?
within the next 2 years. But that is interesting. You mentioned that because I tell you one thing I find quite amazing about the during that COVID period was it kind of
Yeah,
demonstrated just how volatile and sensitive the semiconductor market is, and it
yeah.
really doesn't take a lot to upset the entire thing.
No, no, it doesn't, right? And then suddenly everybody is either is in panic, right,
Mm,
or something's just struggle, and then everybody's like, "What are we doing?" So that's back again, right, to what I was saying. Single sourcing is is a risk.
yeah.
So that's why it's so important to make sure that upfront that you have approved these components on your bill of material, right? That you know that you can just swap it up or switch it out, and that's where we are really good fit.
Mm. So so in that area of supply chain issues and trying to catch up
Yeah.
with the trends in the markets, how has that affected the ability for engineers to keep up with new technologies? Because one thing I can imagine being an issue is if you buy too much stock of an older product and then you're using it for a few years, and then by the time after a
Yeah.
few years it's already out of date. How is
Yeah.
that affecting engineers?
Um, I think there's both side, right? Because if you look at yourself as a consumer,
Hmm.
how often do you now change your mobile phone, right?
Hmm.
I think the quality of what's coming out, the battery life, everything is getting a longer life.
Hmm.
If we're looking just, I think, on the consumer devices, so the demand of saying, "Oh, I need a new phone every year," is not the same, right? The same if you look at
Yeah.
your laptop, the battery is can stay longer and longer without needs to be plugged in, which is giving freedom, right? That's what we want.
Hmm.
So I think the to come out with something new, it's more the whole integration on the new devices, right? That's where I think it stands out. And if you look into the industrial, a lot of things are happening right there as well. We have the whole solar panel, right? We have that's just so many things or different motors that you need to have if it's like a I don't know, different robots or something like that.
Hmm.
So it's it's you need to bring the technology or provide all that. What are your options, or what how can you set it free, right?
I think that's actually a very valid point when it comes to tech, is the fact that people really aren't changing devices as often as they used
Yeah,
to. I've
yeah,
seen it with my wife's phone; she's still using the iPhone
yeah,
13. You've got the cost of crisis
yeah,
situation. The cost of living crisis. My apologies. Which means that people are
yeah,
spending less on electronics, and they're trying to refurbish or try and make things last longer.
yeah.
And so, do you think that kind of mindset is actually hurting the ability for engineers to innovate more quickly, because the chances of them being able to sell those designs is reduced?
Good question. Um, I think it's a split, right? Because
Mm.
if we talk about consumer, the consumer habits has changed.
Yeah.
You have your phone longer, or your laptop, right? You're not changing things out
Yeah.
that fast. But um, I'm sure it's a little bit more different maybe when you look in the industrial or the manufacturing, right? What are you going to invest? Because there you want to be more efficient, and you will actually spend the money and saying, okay, let's get this big machine in, right, or this
Yeah.
robot in, so we can be more efficient. But you're changing around the roles. Um, it, I think it. There's a balance there, and we need to, or maybe it's a plateau we need to hit on saying,
Mm.
what is the demand, but. But for an engineer, and I'm an engineer, right? You want to design something new. You want to be
Mm.
a front runner, right? You want to be there. That's something new. So it's also important that with all the components that's coming in to give all these new great ideas that the design engineers can then develop and design and bring products to market, you need to feed them all these new ways so they can combine it and create
Mm.
even more amazing products or devices.
And I suppose that if development cycles take longer because people are buying less, it actually gives engineers more time to try and figure out how to use those technologies better before they put something onto the market. But my next question would then come on to MCC and how that helps the
Yeah.
engineers. So I can think of a great scenario where I believe MCC might have been very, very helpful. But here we go.
Yeah.
So during the COVID times, I remember there was an unnamed manufacturer who was buying washing machines to essentially take the parts out and put them into cars because they had literally run
Oh,
out of supplies. So my
yeah.
question to you is, if I was a manufacturer, an automotive manufacturer of vehicles, and there was a particular automotive part that I couldn't get anymore, like a discrete semiconductor, how would
Yeah.
MCC help in that situation?
Oh, we have, so we're like global, right? So we have
Hmm.
FAE and we have sales on the ground in like 20 countries in the world.
Hmm.
So I think that makes us also to go in and go into that office and help and be a support and be that extra arm, for the engineers or for that design team.
Hmm.
Go in and saying, okay, how can we help with what we have, right? Or what will be the best match, and then also create a whole strategy on the supply. Should you come out from China, or should it be the China plus one? So
Hmm.
that's where we can get in. And I think, again, getting that personal touch and get support and be on that phone, and you're not just a chatbot, right? Is really important. And that's what, if you go to the website as well, we have made a few enhancement, right, to make more parametric search, so to support or doing a cross and saying, hey, if you're looking for
Hmm.
this, or you're looking up a number, right, or you're looking up a specific characteristic, right, to say what is coming up, but then you can still hit that wall and saying, oh, I still need support. That's where we can come in and be that extra arm, and
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 that's
and
the
so and so
customer service is
and
customer
so
centric,
essentially
right?
and
It's
so
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 important.
essentially you can help customers in a situation where they're looking for, let's say a MOSFET for an EV, and they just can't find it anywhere. They could go to your
Yeah,
site, try and look for the characteristics, and if they can't find it,
yeah,
you can then step in and say, look,
yeah.
we can help you find the right part for you. And but is that something that MCC could also manufacture to custom as well?
It depends on volume, right? No.
It depends on the volume. If we're
Yeah.
talking millions, then yes. Well, but that makes perfect
But
sense. You can't buy 5 transistors from a
no,
company
right?
who
It
needs
is.
to make
Yeah,
10,000 on one
yeah,
wafer alone.
yeah,
But
yeah,
let's say
yeah.
somebody did need like 10 million parts. That is something that you guys could step in and say, yeah, we can
Yeah,
make the
because
wafers for
again,
you.
right, we have it from the raw material, right? We have our
Exactly.
R&D centers as well. So we have it from the beginning to the end. We own
Hmm.
the whole process there. So of course, yeah, that is an option.
Hmm. And how long does that how long would that kind of process take from start? Let's say like a particular, let's say an automotive MOSFET. How long would it take to go from start to actual like finished packages? Do you reckon?
Yeah, hours and hours and hours and weeks. No, it takes a lot, right? Because also with the automotive, you need the IECQ 101, right?
Of
You
course.
need that compliance to be approved as well.
Hmm.
So that takes it's testing and hours and all the quality. So it does take time.
But from like
So
a
I
production,
can't I can't pull out and saying, oh, it's
no,
X amount of weeks.
I was going to say, but like from a production point of view, is it like a 6-month period from start to finish for the wafer? Or would you say it's kind of like a 3-month period? What do we look? I'm just kind of, because I've always been curious about that, because I know that processors from Intel and all those companies, they'll take
Yeah,
up to 24 months, 12 months to produce one of those things. So
yeah,
I'm just kind of curious how
yeah,
long you guys can get something out from a wafer
yeah. So I have to come back with you with that number because
with
I
that
don't
number.
have it ready.
Oh no, that's a shame. I would love to have known, because I'm always very curious, because I understand that I understand they're very complicated processes, and the
Yeah.
fabrication times are ridiculous. So I was always curious, like, if you want a MOSFET, how long is it really going to take before you go from MOSFET to a device that's actually out the foundry? So I've always been quite
Yeah.
curious. But no, I appreciate that it's also a hard number to figure out, because devices are different. A diode might take 2 weeks, but a MOSFET could take 2 months. So because they're all varying devices.
Yeah.
So another question for you then. So if an engineer wanted to get a custom part made, what would they do? What would be the first thing they would do with MCC? How would they contact you?
They will have to reach out, right? Of course, to either our FAEs or that sales account, a salesperson that we have in that country, or they can just can contact us on the website. But I want to direct here and saying it's not that we're doing custom like every day, right? It is mostly what we have in our portfolio, that how we support our customers. But again, we can support and find the best match if it's like a direct pin to pin, right? Or if it's just something that's really close to what that customer is looking for.
And that's actually quite useful. So you can give the option for customized silicon, but if it's like what's the word? If you've already got one that will do the job anyway, you can just say, "Hey, we've already got this part. You might as well use this one." So if I remember correctly, did you say 10,000 products? How many have you
Yeah,
got
we have
at the
more.
moment?
Yeah,
You have more than 10,000. How
it's
many have
more
you
than
got?
10,000. Yeah,
How many more? How
I,
many?
I think we're close to 15,000. Yeah, and then
15,000.
25% of these is actually automotive
I mean,
certificates.
that's
Yeah,
a lot. So what? That's like
yeah,
5,000 ish, maybe 4,000
yeah,
automotive
yeah.
parts,
So
and that's ranging from the whole kind of like things like diodes. We're talking ZVSs. ZVS is it? No, TVSs. Sorry,
CBS.
TVS.
Yeah,
Yeah, that's the
CBS.
one. So all those kind of devices,
Yeah,
and
yep.
so like I say, if a customer can't find that part, they come to you, and then you say, we've got this alternative, this would definitely work for you. And if that was not even the case and it was a really large company and they had the volume, they can come in and go, yes, okay, let's build you a custom part, which is absolutely
I think
fantastic.
let's talk, right?
Yes, let's talk a bit more. Yes, but that's actually fantastic. And one more quick question. You said you do silicon carbide devices as well.
Yeah. So, but we're still in the beginning of that one. So, yeah. So we have, and again, if you go to the website, you can actually search on the different categories that we have a product we offer, and you can click on saying new product, and then you will see what we have. We wanted to make it much more easier to navigate and find what we're actually bringing to market.
Absolutely fantastic. Now, just before we wrap up this podcast, I've got one more question for you. For the engineers who are watching this video, if they want to use your solutions, or they want to, see your services, and for large volume silicon devices, what would you recommend that they do?
Definitely check out our website on mccsemi.com. So check that out, and then just reach out to either to me, right, or find out who's in their area, if they need that extra arm, right, to look at that bill of material, looking for that single multi-sourcing opportunity. We're here to help, even if you just need some help to cross. We have the brain power for it. We have the engineers that can go in and support, and it's all about have that customer-centric approach, is helping us to bring awesome products or devices right out to the world and make it more digital.
Absolutely fantastic. Thank you ever so much for being here today.
Yeah, thank you so much. It was fun.
Thank you. And I'll see you next time.